Hi, welcome back to this video on mechanics of forecasting methods. I am Piyush. We have a series of 5 videos here. The first was on moving averages, second was on exponential smoothing, this is the third on trend lines, two more to go on seasonal indices and measures of forecasting accuracy. As far as trend lines are concerned, they're suitable for data with random variations and trends. They're not suitable for seasonal variations. And like all other quantitative methods, we use trend lines only for short-term and medium-term forecasting. Generally, we do not use quantitative methods for long-term forecasting. Let's jump into our first set of data. Data here is about takeoffs from India by scheduled airlines from 2003 to 2011. So in 2003, we had 263,870 takeoffs. In say 2006, we had 453,921 takeoffs. We will first try to create a linear trend line. A linear trend line is of the form of y equal to a plus bx. So here y would be the forecast or the demand where we use the past data. X is the year of interest, a is the intercept, that's the base level demand or the base level forecast. Graphically, a is the point at which the line would hit the y-axis, and b is the slope, or it's also the trend. So b is the growth year on year in the number of takeoffs. It's a very simple method to create a trend line on Excel. We first select the entire data. We have selected the labels so that it reflects in the charts. We go to Insert, Scatter Chart, and then we select the first scatter chart here that has without the lines. We have the data here. Let me delete this label so that we may expand the graph. This seems more or less linear. We can put the cursor on any one of the points. We can put it here, we can put it here. Right click and we get this menu. We select Add Trend Line. We want a linear trend line, that's selected. The trend line name is takeoffs, which it takes from the label here. We want the forecast for the next 2 periods. We want the equation on the chart and also the r-squared value. I'll tell you what r-square is in a while, and close. Here is the equation for us. Let me take it here so that it's easily visible. Okay, so the equation is y is equal to 57,512x minus e something. Let me make it easier for you. I select this data, go here, format trendline label. These are numbers, and let's say we need 2 decimal places. Close, and let me increase the font. I select this, we go to home, we increase the font to 12. One thing you could alternatively do is make this a full screen so that you see the numbers better. So we have the numbers here as per the equation. Y is equal to a plus bx. Shift this here a bit. Y equal to a plus bx. So the a for us here would be a for us would be negative 114,931,084. So I'll write the number is negative 114,931,084. I'll ignore the decimals. And the b, the slope, would be 57,511. We'll ignore the decimals again. So that makes it 512 rather if I round it up. So r square is one more factor which is there in the data here. R square tells you the strength of the relationship. It's called the coefficient termination, and it varies between 0 and 1. If r square is 0, there is no relationship between the two factors we are comparing, and if r square is 1, it's a perfect relation between the two factors we are comparing. Since our r square is 0.94, closer to 1, we can assume a good relationship between the year and the takeoffs. So I can predict the takeoffs, the predictions that we have. So for 2003, my prediction would be equal to A, Y is equal to A plus B multiplied by X, which is the year, and enter. So the prediction was 265,452, which is very close to the actual. Let me fix the A and B, which is E6. So let me fix up the 6 part, and we also fix up this one so that I can double click this and create the data for us. So as for this, in 2012 the number of flights would have been 783,060. This is a very simple linear trend line. Well, trend lines need not be linear. Let's have a look at another data that we have here. This data is about broadband internet subscribers, again in India, per 100 people. So we have data from 2002 to 2011. In 2002, with 100 people, there were 0.01 people owning a broadband internet connection, and in 2011 we had 1.08 people owning the internet connection. In this particular example, we have replaced the year with a code. So 2002 is replaced by 1, 2003 is replaced by 2, 3, and so on. Is it compulsory for us to do it? No. I'm just trying to use it as another example of something different. We select the code and the broadband penetration. We have selected the labels again. We go to insert, scatter chart, the first set of data. Again, I will delete this label so that the graph expands. I put my cursor on any one point, right click and say add a trend line. I can have exponential. You can try out with other formats here. We want the display equation. I want the R² value. And I do not want prediction, but we can ask it to give us prediction for the next 1 period, 2 period, or 3 periods, or whatever. And I close it. Let me shift this label on a little bit on the left so that this equation we put it here. I'll increase the font size of this equation so that you can see it better. Perfect. The equation in exponential generally varies. Y is equal to A e raised to bx, where y would be the forecast or the demand, x would be the year or the code, and e is a constant 2.718. Excel makes our task very easy. Let's understand what our A and B are. In this case, the A is 0.006, 0.006, and the B would be 0.5768, 0.5768. Right, so we have the A and the B here. So let's get to our prediction. The prediction would be equal to Y equals to A, which is this one, multiplied by e raised to, for that we put exponential. So it says it will directly give us e raised to whatever we want. Bracket open, B multiplied by X. In this case it's not the year but the code. Bracket closed, enter. So as for this, the internet penetration would be 0.01068, which is very close to our actual number. I go back to the formula, fix up the A's and the B's, which is $3 and $2. Double click this so that we get all the values. So these are my predicted values or for the years, and for 2012, which is the code 2012, which is the code 11, you would get a forecast of 3.41 people per 100 people having a broadband connection. This is a substantial jump. Well, that's about it on trend lines. Thank you very much for watching. Do like this video and share it with your friends. My email is here. Communicate. Let me know how you liked it. Thank you.